Welcome, everyone. It's my pleasure to introduce Francesco Bertolotti, who is a postdoctoral researcher at Luke, and he will talk today about simulating social systems in various ways and what he's learned in doing so. So, Francesco, please.
Thank you. Thank you for inviting me. It's a pleasure. And yes, beside the catchy title taken from some J.K. Rowling saga, the overall idea is exactly what you've said. So, what I am doing in my research is basically about not exclusively, but basically about simulating social systems, and which means that I'm working simulating different kind of social systems, and I'm working on different fields. So this is what I'm gonna talk about. But before actually to start with the research, a little bit warning. The first is uh, things I'm showing, of course, are things I'm a little bit proud of course, because otherwise I wouldn't show them. But third is research is victory in defeat. Truth is, research is not like, let's remember that research is not like being able to present some nice product, to have some nice paper on a journal. Research is all the process of struggling and struggling sometimes, and that is actually the victory in the fit. Even when things are going bad, and things went bad most of the time of the papers I will show you, it still is research is what push you to keep on trying and keep on trying. So that's the first meaning. The second, I'd like to focus on the ideas and not on the results. In one case, actually, I won't have big results, yes. In others, I would have. But still, I think uh, is more ideal if the overall purpose is to engage into a conversation to focus on that. Which means that if you ask me for the result, I will just give you. I'm not saying that I'm hiding them, but I will focus on them, of course. I will focus on the ideas and not on the results. The third one is that, of course, as I presenting this like as myself here, and I'm presenting a few things, but no of this research were made alone. I always have collaborations. I have actually wide set of collaborations. I'm working with different people, and I'm really grateful of all of them for being able to work with me and so on and so forth. So, of course, I'm describing some research, but of course, it's not something that I did alone. Okay, said so, let's talk about some work in progress. And in the word of the great philosopher Michael Scott, let's do some parkour in the sense of I'm not going to show you on one research and dig into that because I kind of think that this kind of events they have the purpose of being inspirational in the way of inspire some new ideas. And so I thought the more I show, the more new ideas, new suggestions, new sparks could be generated. So we present you three different things plus one. The first one is a project which is now by now is a long project. It's like the fourth year about modeling emergency care departments in Italy, of course. I mean, as you know, may notice from my accent and my name, I'm Italian. I didn't have to specify that. And the second, the epidemic version of the alpha rollbar problem. The third is a simulation of the Mediterranean trade during the Iron Age, and especially we will discuss this later. And finally, some other stuff I'm working on. Just bits that I leave there. I'm gonna leave there. So, said so, I will start from the first one. Of course, I will make like one slide each. I'm not gonna deep into each of them. Otherwise, I will talk for 2 hours. And this is actually a kind of nice process. It is a nice process because it started from one question that a colleague of mine in my university, Luke, uh, had this in September 2024. We have some kind of European fundings to use as Italy, I mean. And one of these European fundings were allocated to make new emergency care units. Something have a different name as just to align on the main thing. And the main point that is where and we were wondering where should an emergency care unit be located, the next one in our area. I have no contacts and no one in that world, but it's not the same for him and for the professor he's working with. They are working in healthcare management for like 20 years and they know a lot of people there. So the moment we had that question, they were actually able to get data from the region of Varese, which is the border regions between Milan and Switzerland in the northern Italy, and getting all the data for 2 years for all the data for 2 years for five, six actually, emergency care departments in five different cities. In this way, we were able, we, we had the possibility to study a lot of things. We did an agent-based model to define whether to allocate uh, the next emergency care community. But most important, to do the agent-based model, we needed to understand precisely how do the patients behave. Because actually we didn't have idea about that. Okay, we have the intuition that a patient could go to the closest place, and actually some literature, some kind of gravity models were presented confirming more or less this hypothesis, with no strong results, but confirming more or less that hypothesis. And so we need to find some kind of physics way that would explain the behavior of single patient and would explain it easily. And we arrive to this formula, and which actually is great because it explains 98.3% of decision of patient's decision, which is a lot, at least compared to the previous literature, and it relies on a very simple assumption, which is, of course, the father is the hospital high from the patient K, the less is the probability, the chance for patient K to go to hospital high. But on the other side, the bigger is the hospital high for number of beds, which is the factor B, the more chance you have to go to that hospital. Of course, if you are far from a small hospital, it's very unlikely that you will go to emergency care unit there. But if you're far from a big hospital, it's more likely that you will go to an emergency care unit there. That is the first step of adding. The next one is cool. But if we had in the data the triage code of each patient, which is the level of severity of each patient, and we elevated for B. So the importance of the number of beds is as high as if you the more you are serious, the more the more you're serious, the more you need emergency care unit because you are very 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 serious code. Then the more important is for you to go to a big hospital. It's very simple model. It's very explainable. It's intuitive. Like, of course, if you are dying, you want to go to the hospital that can save you, not to the small one. Even if they're in the same distance, even if the small one is just a little bit closer, because you need really good cures. If you have like something which is very not important, of course you will just choose the smaller one, or will choose with more likelihood the smaller one. And so we found this nice we found this nice model, gravity model, enhanced gravity model, which actually worked, and that was the baseline for our for actually our agent-based model lately. And then we had the chance because we won another grant to keep on studying this topic, and so we start studying not such the allocation, but the overcrowding of the emergency care unit. And this is something that we don't have result on because it's something that is a really work in process. And by now, what we are doing is trying to use um, some kind of Markovian model, something easy, which we want to use for a specific reason. We do not want at all to consider the overcrowding in the way that is considered now, which is with the perception of the people, because we don't think it's a good idea. We want to find some kind of metric and some kind of way of measuring that, which is uh, which is actually better, which actually takes into consideration the amount of work that is needed. So, given that we have a lot of features for each patient, we can actually use this Markovian model to assess both how full, let's say, it is the treatment stage, and how full, also with the complexity of the patients, is the waiting queue right now. And in this way, we didn't do yet, we likely will do in the next 6 to 9 months. What we did yet, what we aim to do is to find a new metric which is actually working better and objectively to measure uh, emergency care overcrowding. So this is the first thing, the emergency care department. Here it was kind of easy to work. We have a lot of data. So when you have a lot of data, it's always very easy to work. Uh, then there is the second one, which is actually kind of the opposite. The idea came from just an intuition, which I wrote down on my notebook once, 4 years ago, something like this, a very long time ago. And which was like, can't I study, can't I add just an epidemiological dimension to the health urban problem? How does the social dilemma affects the epidemiological perspective, the epidemiological dimension, the Sears in that case, dynamics, and how the Sears dynamics affects the social perspective. And this is just the opposite, because in this case, this is just a purely theoretical work. This is not like something empirical based. I don't think it will ever be, actually. And that was just an idea. As long as I didn't find two brilliant students, bachelor students, which actually is good. They're gonna graduate next Wednesday on the two theses on this problem, and they got really into that. And so we start working together. We start meeting sometimes, and then we start to exploring that dynamics. So the overall idea at the beginning, we made the model. They made the model. Actually, was supervising them, and they made the model, and we find out together that actually the two dimensions were kind of intertwined. And more important, what we find out that the finding it could have later been validated for empirical scholars in a way that see if it could be relevant for decision making or not, was that the information in the system is something critical, for the sense of if we are able to provide to individuals more information regarding their status, increasing the acknowledgement they have regarding their status, then what we can achieve is that the epidemics could be fought better. I mean, could just expire by itself more likely. So this is the first element. Then one of my students, got really into reinforcement learning. And he was got really into AI. Actually, he changed university now. He's doing a master on AI engineering. Kind of proud of him, actually. And what he did, and what we actually I suggested him, say, if you're really into that, we could. No, actually, it was after. Sorry, before passing to the reinforcement learning. Sorry for that. We studied the dynamics of the model, not only the effects. And what we found is that they have an amazing matrix, amazing dynamics, which could changes a lot in different shapes, which are recursive, just changing few parameters one to each other. This is the map of all the dynamics which are connected to each other. And okay, now I don't remember exactly how to pass from one point to another because it's a couple of months and don't look at it. So I should check, for example, how to get from hourglass to multiple triangles. But what it was very interesting is that there is a semantic meaning to that. I mean, whenever you're changing the shape and you're observing the change of parameters, and the connection is between the closest possible shape, you actually see a semantic meaning between passing from one to another. And I was extremely surprised to observe such a rich dynamics, where on the y-axis we have the number of attendance of each time step at the bar in the alpha roll pub problem, and on the y we have the number of infected people at each time step. So we are also able to find this very interesting and rich dynamics, which we didn't finish yet to interpret, but it's kind of nice. Then my one of the students got really into reinforcement learning, and so I suggest him to say, okay, if you're into that, just made a policymaker, the government of the El Farol bar, the Santa Fe, because El Farol was in Santa Fe city, and make the mayor the government of that, and provide to the government three possible actions. The fact that you are making a lockdown, so reducing of a percentage the maximum threshold of the attendance. The fact that you force a tester to go to the pub so that sick people could not attend the pub, and the fact that you are forcing people to wear a mask. So you're reducing the contagious rate between the people that are actually attending the bar. And doing this, what he did later, he was training this. What he did later, he was to train a reinforcement learning model, and which he could be able to teach how to make, let's say, optimal decisions with some kind of individual perception. So, whatever the policymaker perceive, for example, a given cost to each infected people, the decision will be a combination. With the increase of the cost, the combination will change. This is very interesting, not only for the fact that he did that, which is just nice, okay, but it's more interesting for the interpretation because it could be interpreted as how can I say, to understand how the actual governments behave during the COVID time. So to get a better understanding, not complete understanding, of course. Third, I have attended and enormously enjoyed the winter workshop complex systems last year. And when I was there, and we mention later how the idea will arrive when we talk about the butterfly effect, but just a little bit later. And when I was there, the project I was working on was this idea of can we understand why the Mediterranean city during the Iron Age, at the end of the Iron Age, so when there was the Roman Empire, basically, had the shape that they actually had. Why so? What are the discriminants? How did it happen? And the other idea is can we see in the trade routes some effects that lead to that? This is a map of the network which was taken from Orbis, a project led by University of Cambridge, if I remember correctly, and which is openly available. So we take the sea trades, sea routes from there, and we got the data from from a another Cambridge University repository of the Roman Empire cities. So we have the dimension of the cities at 1000 before Christ and 300 after Christ. Given though, and given that we have the connection possible because we have the naval routes, and we have some resources because we have the mines, the oil press, and a little bit the grain, but we're still working on that. We are still using dummy data for that. We're still looking for the real data. We were able to actually perform an actual simulation that would, an actual, let's say, network-based simulation, which would exchange from one node to another. And what we find out in this case is that is not perfect, the adherence, but we found that the average error was not very high. It was around 5 or 6%. I should check the same data. 5 or 6% of the mean population, and that we were able to actually interpret the dimension of, for example, Alexandria, of Leptismania, of Carthago, and we have most some difficulties in Greece and Asia Minor, basically because there was a lot of cities that was one beside the other, and so of course the resources were all that, and the success of a city over another, it was kind of stochastic. But overall, we could see that 70% of the dimension around the dimension of the cities were explained by trade in this model. The only issue with that is that we don't have yet, we are still working on that. We don't have good data of grain. It exists somewhere. We're still looking for that. So I basically ask ChatGPT to generate them, something realistic, to start running the simulation and see if it makes sense to look for real data. So since the result by now makes a little bit more of sense, we are working on funding that. So these are the three nice process project I want to talk about. There is some other things I'm working on right now. One is a project related to validation of agent-based model, because I'm basically an agent-based modeler, and I am deeply convinced that we risk to end up like psychology if we don't do something about that, because there is a problem of replicability in agent-based models. So I'm working on that. Very slow actually recently, but I'm working on that. I have just completed a work on the rebound effect in circular economy with some people from my university which are expert on that field. So we did an agent-based model with a master thesis student to try to understand whether the rebound effect is an emergent property or not. And I'm working with Sabir Roman, which is actually, I think, is my main co-author usually, and on a boom burst cycles in innovation market, which is presenting today or tomorrow, I think, at the Complex Next World Conference in Istanbul. I'm working now a little bit less intense. I was more doing during summer, less teaching, so I have more time for research, and on LLM-based driven agent-based models, which I think they may not be the future, but for sure they're the present. So there's something that we need to study to understand, both to understand how it can be used for models and to understand better large language models and how they behave in swarms, which will be super critical in a while, I think. And I'm working on a project of simulating ski resorts with another master student, which is very much passionate about this. Is almost complete that, so I suppose that likely I will present it at the from object to agents workshop in Trento this summer, I suppose, but I'm not sure yet. And then I'm working on a project again with Sabine Roman, again very slowly in this case, about European history, territorial diffusion. And so that's all. If you have any question or any discussion, I'm really glad to discuss it. And if you want to reach me, you have my emails there. I'm actually I've now some positions open. So if you are looking for job in complexity and social simulations, and you could reach me, we can have a conversation in case. So thank you very much. Whenever you have questions, I'm here.
Thank you very much for the talk. This was super exciting. Do we have any questions from the audience?
I have a
Yes,
question.
go ahead.
Can you show again the slide about the population in the Mediterranean trade network? Because that was interesting because it showed that your biggest error in prediction was Alexandria, which like if you take the opposite means like that the trade network accurately predicts the patterns of population in most of the other cities, right?
Yes, we have bigger errors. The first one is leptismania, and the second is I mean we have that cities there. So Alexandria and leptismanias were under considered because Alexandria it actually is not a big mistake. Relative is a big absolute because it was one of the biggest city in the world at the time. So actually the variation is not so big relatively, and it has the same reason of leptismania. So I will explain in a moment. Leptismania is in Cyrenaic. Cyrenaic is the region of Cyrene, which is now in Libya, between uh, between Libya and Egypt. The one in the middle that is doing this shape, basically, the curve shape. That is a fertile region, and it was even more fertile 2000 years ago. And so basically, the reason why there is such a big mistake, I think, I'm not sure about this, but I think is because the data we have that was ChatGPT generated about the grain, because it was like dummy, were not really precise. And there was more grain produced there than what actually was in our data. This is the first tentative. The second reason could be that it was another kind of products was produced there. For example, fruits or different things which were not grain. I'm really not an expert of Roman Empire economics, and one could say you shouldn't do this kind of research if you're not an expert. And I'm trying to talk with people that knows more than me, but we are all complexity scholars basically. So is I had a call 2 months ago with an expert, a real expert of Mediterranean, like Roman Empire naval trade network, and he's studying only this, for example. And when I was talking with him, I was like, "Oh yes, of course, what I was doing." Like so, it requires some kind of attention. I mean, you're taking data sets provided by people that relevant people by uh, reliable sources. I mean, the result of a project made by Cambridge University, I consider as reliable sources. But of course, then you have to talk with the people that knows history really, not the way I know that, which is I know that because I like it a lot. I read a lot of books, okay, but it's not my topic.
Yeah.
So this is for say, leptismania. The other mistakes, Pelusium is a lot because Pelusium is just beside Alexandria. So the difference between Pelusium and Alexandria is basically compensating. It should be there, but since the proximity of the resources, it cannot be allocated, which honestly, in my opinion, is fine. It's okay that such a simple model is not understanding all the variability. And then we have Ephesus, Nicomedia, Athens, Smyrna, which basically are places very close because they're all in the Aegean Sea. And so was not other cities take that their bigger place, which are just close by. So in that case, the bring home message should be, if you want to be more precise, you need to aggregate more the cities in some areas. Because if you're traveling in the Aegean Sea, in the sea, it's more or less very simple to go to one place to another. You have a lot of islands in the middle. So such a simple algorithm do not consider the fact that, for example, Ephesus or Athene were kind of really important even cultural cities. And so this is also the reason why they became so big in the meantime, not only trade.
Thank you. That was very interesting.
But thank you for the question, of course.
That is really, really interesting. I think in the interest of time, let's switch from this to the discussion part. And I think, Francesco, you said you have another slide deck to introduce this a little bit. So,
Actually, I don't know how much I did I talk because I didn't really. Oh, a lot.
uh,
Okay.
it, it's now, well, we're now 40 minutes into the seminar. I think absolute time might not be that useful given that we're in multiple time zones.
Okay, so I will just do some. This is gonna be quick. Okay.
Sure.
Uh, is a little bit personal sometimes, but I want to send a message. That's the reason why. And I'm talking basically about my failures, not my success. So it's like it's not how celebrative, or whatever I'm saying that. So butterfly effect. So I was born in 1992, and I was very affected by a few things that I have no idea they will affect my professional life. I wouldn't develop such a taste for modern historical phenomena if I wouldn't be playing Civilization 3 as a child, teenager. Okay, that that actually really looks very dumb on one say, but that's actually true. Uh, it's a butterfly effect because my father brought it home one day saying, "This is not very good. We shouldn't play that." And then we change our minds. It's the same. I wouldn't develop the taste of modern historical phenomena if I wouldn't read Asimov Chronicle of Foundation books. This is actually the exact edition that I read. And I remember actually the day in which I started reading that. Such was, I don't know, it was a nice Sunday. I really enjoyed that. And that actually was foundating my existence, in my professional existence. I knew 20, almost 20 years later, I found out that that was important. Then, uh, then I stopped thinking about that, about the fact of, math is nice, history is nice, things can be combined in this kind of funny, and modeling is fine, it's nice. When my high school professor basically told me that I was an idiot doing that, and basically stop me from doing that, which is, by the way, another effect of another idea of butterfly effect is very tiny. She say basically, don't do that. She just say that. But it really has an effect on me. And I can recall now the effects on that. So our research is affected by small things. Then I okay, studying, but this I can uh, I will actually just keep this with a simple sentence. Okay. I was supposed to I was not a good student in high school. I was a terrible student in I was a terrible student in bachelor. I really didn't want. I graduated very late. That's a picture of myself much younger, just graduating. And then I was rejected by the university I was studying in for the master. And uh, and it was the best thing that ever happened to me because I studied industrial engineering. There was not. I would never have met complexity science otherwise. When I went to UK, which is the same university I am now, and UK is actually in the first and the second term of the first year of master, is actually two exam. So in autumn 2015, I discovered network science. that I would never have discovered otherwise. And in February 2016, I discovered simulation modeling, which is actually the exam that I'm teaching now at the same university. And then I fall in love with that. Also, network science I love a lot. I fall in love. Again, I couldn't enter in the master at Politecnico for a very tiny bit. If that wouldn't be, my life would be complexity change, but also my research. Maybe I would have been a researcher, but it would be an industrial engineer, not a complexity scientist. And then, of course, I graduated, I start working. Okay, but this is, I don't want to focus on that. Let's focus on the funniest part. So, I start a PhD in 2018. 2 years into the PhD, I was kind of struggling for many reasons. One thing that changed it a lot is that I may have been a little bit hurted by my high school math teacher, but I still have the taste for that kind of things, for history and math. So when I attend the Complex Systems conference in 2020 and I see Sabine Roman presenting 2 papers on that, of course, I start talking with him. I went to the poster presentation online because I was during COVID. And basically, from that, I started my most prolific uh, collaboration and also friendship because by now he's a friend of mine. And it was really changing my career that the fact of having someone which I'm talking every week and just chatting about research and just, not your supervisor, it's different, he's a peer. And discussing about things, working with things together, struggling with reviews, and that really changes a lot. And nevertheless, even in that case, again, I told you I was talking more about failure. I was kind of lucky because I was kind of unlucky because I really mischose the reviewer of my PhD thesis, and he basically failed my thesis when I was submitting that. And so I spent 6 months basically studying and revising things. And that made me such a more mature scholar that I have no idea before. I was a very mature scholar when I was going to graduate as a PhD. I mean, I see now in perspective. The fact that I failed that, as I failed before the admission to the PhD first time, and I failed before the admission to the master the first time, and it really makes me a more mature scholar. So it took me 5 months, 6 months to graduate more, but it really did not change because at the end of the day, I was ready to write more, to study more, and also I was more mature to interpret the behavior, what was happening with ChatGPT. Because another thing which is totally unpredictable, at least it was in my life, I was not an expert of artificial intelligence. I'm not even now, honestly, in 2021, 22. But now I'm coming from a class on about using ChatGPT. It changes a lot with that. And the day after, I start my postdoc. So basically, I have the assistant I needed to work and something that I wanted to study also. And I had the possibility of doing that because I have a long-term postdoc to do that. And so basically, again, butterfly effect. In January 2023, just started the postdoc. A professor friend of mine came to me and asked me, for consultancy, can you do just a quick time series analysis of some pharmaceutical consumption? We did that. And 6 months later, we were presenting that in front of the Ministry of Healthcare in Italy, which was nice for 2 things. First, because I did that. Second, because I present in front of a lot of important people with my tie. If you look at the picture I put for that, which is reverse because I wasn't able not to put ordinary. Okay. And the second was the fact that I was reading a book about the history of Carthago just before go to the winter workshop of complex system. And then I was starting that project I show you just randomly. I pick the Brian Warmington book for history of Carthago randomly for the library that day. And it changes a little bit of my professional life again. So The idea that I'd like to discuss with you is research is the marriage of serendipity and determination. It is impossible to predict what will inspire our best ideas. It wouldn't be a game that we are playing when we're 11 years old. It will be a book we are playing one day after we miss a football match. It will be just a random things around. And I consider research in a way as a therapy because whenever you're doing research, you're really discovering yourself. And something nice that it just takes one single element from meeting to ignite your passion about something and go to the next clear step. The same way it happens with me with ChatGPT in a certain moment, and before it happens when I met, for example, Sabine. And finally, we all know that life is really sensitive to initial condition and also research. So we cannot really predict what's going on in the future. We can just know what has happened and learn a little bit from that. So I wanted to say just some slides just to arrive to these points and to show why I believe in these points, basically. And that's all. This is the topic of the conversation.
That's Thank you very much for sharing your journey through academia. That was very interesting. Maybe I can start off with a question here. How do you think that relates to your own work in like simulations in social systems, right? If everyone's personal journey is so dependent on initial conditions that you say, what does this tell us about the predictability of social phenomena, especially if we think of like simulations and studying history?
Well, there are two answers. One answer should be I am. One answer is it's not possible, but I don't believe in that answer, honestly. The second answer, the three. The second is as long as you study bigger enough numbers, you can at least inside in some way go to the main field, consider the main field, and then not consider the individuals and what's happening. But this is the Asmus answer, which is not even my answer, to be honest. The third one, which is mine, is it really depends on the power of your intuition. The point is if you have a good enough intuition about a phenomenon, even if it's deeply unpredictable, you can understand how it is generated. If you understand how it is generated, then you don't need to predict. I mean, you can say it is not predictable, but you know that. The point is saying that it's not predictable because you don't understand that. And so it's not that it's not predictable, it's that you don't understand that. So what we should do there in that field, I think, but in every social system field, is that we should struggle to get the more and more intuition to validate our intuitions with data because data is always the king. At least you can do theoretical stuff until a certain point. Is you can be a completely good theoretical scholar for your career, but you need someone else then validate that on the empirically. That's of course, and then you have good intuition. You validate with data, and then you see if if the phenomena can actually how uncertain is that what's going to happen. In that case, you say, okay, sometimes you can do some predictions, sometimes you cannot. Sometimes you can assess distribution probability of an event, which is still good. I mean,
Mhm.
prediction, honestly, you cannot really predict anything with 100% accuracy. So as long as you can actually predict the uncertainty and not the outcome, it is fine. The uncertainty of the outcome, not the outcome per se, is fine.
I have a follow-up question to something you said about the chat that you met by chance, one of your most frequent collaborators. Can you highlight maybe how like the butterfly effect or how chance made you meet all your collaborators that you talked about, or like highlight what areas your collaborators come from and how you met them? Like just not long, but like just to get a grasp of like
Okay, actually, I jumped for this line presentation because I didn't want to be too long. Okay, for the healthcare, for example, one of them, like there is one person in this research center which is working there for a long time, for a while now, it's 6 years, and he started working there. He was a friend of mine for the master, and he started working there when I started PhD, more or less. So for 1 year, he liked to smoke a cigarette after coffee, and yeah, we were friends. I'm not like a big smoker or something, but I like spending time in company. Sometimes I would smoke a cigarette in company with pleasure. So I was going down with him, down from my office, and go to the bar, take a coffee, and smoke a cigarette. And but of course, he was not there alone. He was there with his research center. So his boss, which is the professor, the chief of the group, got used to see me, but she has really no idea what I was doing. Look, what I was doing. And so one day she forgot the wallet, and I just wanted to be polite. I offered her the coffee. It's like 1 year of coffee. I just wanted to be polite. I don't know. Then she asked to finally, after 1 year, she asked to my friend what he's doing. And, he's working on engine-based modeling, so on and so forth. And she was like, "Oh, you really need that." Couple of months after COVID struck, they were the healthcare people at the university, and I was the simulation person, the simulation person at the university, and so basically, and we were in a very good relationship. So basically, that it started like that. If I wouldn't go smoking cigarettes with my friends for the 1 year, that wouldn't happen, which is very dumb, but it's a lot of research on that. And other things. Uh, the one of the Alfa bar is the two students. I got to know them a little bit better because I did a teaching the moment between the PhD and the postdoc. Of course, I have no money, so I have to do something to survive. And one of the things I did was to coordinate a group of students writing a book game to teach data science to high school students. Two of these students were the two students that did the Alpha model. So I was in a very good relationship with them. Sometimes after that, I was meeting them in the corridors, in the bar, and they were stopping me to chat, to ask for suggestion or something. I like them, so I was stopping with pleasure. And then one day they asked me what I'm doing for work, and I explained them I'm doing simulations, so on and so forth. And they were like, "Oh, very nice. But can't we do that as well?" I said, "Okay." I have an idea because I have that idea written on the note, and I've just checked that idea on the note the day before. So I could remember, and I say, "Okay, let's try to do that." And so they try to do that, and the work keep on. With Sabine, again, if I wouldn't be passionate about history, I would never have met him, of course. And I would say something. I mean, meeting at the conference is different, the real conference, because of course you're meeting, but it's the place you're supposed to meet. And basically, that's all of the weird things. But it already makes me one of the luckiest scholar ever lived. Just basically, I know that I met a lot of people by chance and really unlikely situations.
Yeah, that's so cool. Like especially the first the smoking thing, the smoking example is so cool, such a cool story. Thank you.
You're welcome. Actually, there is an addendum to that, which is we are still doing this finger smoking. So I'm collaborating with them, like a research affiliate now of the research center. So whenever we have to coordinate, I'm just going there. Now I'm buying my own cigarettes because I cannot just take cigarettes all the time. We are smoking a cigarette and we are coordinating about what to do. There is
That's
still things on, yes. I'm not smoking usually, but with him I'm smoking.
I mean, that's incredible.
Well, thank you so much for sharing your stories. And I think we're at the end of our seminar, and I hope it's similar to the smoking, something that brings people together, maybe in a little bit healthier way. Um, So yeah, have a great evening or rest of your day, depending on where you are. And well, thank you very much.
Thank you very
Goodbye.
much.
Bye
Thank you,
bye.
Francesco.
Thank you to you for the invitation.
Thank you. Bye bye.
Bye bye.
Bye. Thanks a lot.
Bye.